is very, very similar to 7.1, as today we are looking at exponential decay functions. So I'll try to make this as quick as possible, but exponential decay functions has really the same form as an exponential growth function. The only difference is that our b value, so the base of our function, the decay factor, has to be a number that is smaller than 1. So that tells us that our decay factor is most likely going to be in the form of a fraction. So as you can see by our first example here, our base in this case is going to be 1/2, which is less than 1. So if we were to substitute these values into 1/2, I would have 1/2 to the negative first power. Remember, negative exponent, you take the reciprocal. So that would turn into 2/1 to the positive first power, which just gives us 2. Okay, anything to the 0 power is 1. And then 1 is just the base, so we would have 1/2. So as you can see by our graphs on the left, the table that I just created is obviously for the exponential decay function. So as you can tell, these are kind of opposites of each other to an extent. So our exponential decay is just a fraction, while your growth is a whole number. Let's just take a look at a couple of quick examples. So if I took y equals 1/3 to the x power, if I was to take this to the negative first power, I'm just going to take the reciprocal, which will just give me 3. Anything to the 0 power is 1. Anything to the first power is itself. So I could go ahead and graph this. -1 and 3, 0 and 1, 1 and 1/3. And it's going to give me an exponential decay function that looks something like this. Okay, there are cases, like in number 2 here, where you will have an a value. So what we'll do is we'll take our exponent first and then multiply it by 2. So 1/4 to the negative first power is just the reciprocal, which is 4. 4 times 2 will give us 8. For 0, we'll take 1/4 to the 0 power, which is just 1. 1 times 2 is just 2. And then with 1, 1/4 to the first power is just 1/4. 1/4 times 2 is 1/2. So we can go ahead and graph this. -1 and 8, which would be somewhere up above our graph. 0 and 2 should be a point there. And 1 and 1/2 would be about there. So connecting these points, we are going to get a graph that looks something like this. All right, so I'm sure you guys know this process by now. So let's just take a quick look at page 2 here. This example is just like it's actually the same example as the first one that I did. Let's skip both 2 and 3 because they're very similar to the second example that I completed. And let's just do one of these bottom ones. So with these bottom ones, we just have to be a little more careful with our substitution. So first of all, let's look at our exponent, which would be right about here. So let's substitute in a -1. So if I had my function y equals -3 times 1/2 to the negative first plus 1 power minus 2, I'd first start by simplifying my exponent. This would give me -3 times 1/2 to the 0 power minus 2. Remember, anything to the 0 power is 1. So that's going to leave me with -3 times 1, which is -3, minus 2, which is just -5. So for -1, I'm going to have a -5. And now I'm just going to repeat these steps. So let's go on and move this quick. Extend the page. Let's go on and substitute in our 0. So if I had y equals -3 times 1/2 to the 0 minus 1 power, plus 1 power, minus 2, that would just equal -3 times 1/2 to the first power, minus 2. That's just going to leave me with 1/2. So -3 times 1/2 just gives me -1.5 minus 2, which is -3.5. All right, our final substitution here. Y equals -3 times 1/2 to the 1 plus 1 power minus 2, which just equals -3 times 1/2 to the second power minus 2. Remember, you square both your numerator and denominator. So that's going to leave me with -3 times 1/4 minus 2, which is just -2 3/4 minus 2. Wait, I feel like I've made a mistake here. Yeah, totally. I added these two. So I'd multiply my -3 by 1. So -3 over 4 minus 2, which is just -2 3/4. Or if we wanted to stay with decimals, -2.75. Okay, we can go ahead and graph this. -1 and -5, 0 and -3.5, and 1 and -2.75. And it's going to give me a graph that looks something like this. Once again, we do have a k value of -2 here, so that's a nice way that we can check our answer, because we know that -2 is going to be our asymptote, or that point that our graph won't quite hit. All right, so I know I went through those notes super quickly. They are just like 7.1, so hopefully you were able to pick up on everything. But if you have questions, come to class and we can answer anything that you have. All right, thanks for watching.